This is the DEFCON 31 Space Pony Silly Add-On. It has games, an LED display, and a hackable developer interface, with all design files available open source. These fit inside the official conference badges. DEFCON badges will not be shown until the conference, so is represented here by 3D printed mechanical interface. There are two models of add-on, the Pony add-on, available for purchase at the conference, and the Space Bits Are Us version, exclusively for the Hackasat 4 Capture the Flag competitors. The two models are similar, except the Space version has an additional 12 LEDs in the front and a larger 25-hour battery. The units contain several features, including a microphone, a hackable STM8 processor, precision clock, self-contained battery with charging circuitry, 10 RGB LEDs around the periphery, one status LED, one power switch, and two buttons. The Pony units are available for sale at DEFCON 31 for $20 each, available before and after the Hackasat competition each day in the Aerospace Village. Look for team members wearing the space badges to buy the Pony units from. To turn on the unit, move the slide switch right. Light patterns will immediately begin running around the edge of the device. To turn off the unit, slide the switch left. The software is accessed by pressing either of the buttons. The software is broken into three modes. The first mode is the application mode, which contains 4 menus. The left button is used to select the menu. The right button is used to interact with the menu. Button presses can either be short, less than half a second, or long. A long press on the left button will place the device in mode 2, sleep mode. When the device is in sleep mode, the LEDs are turned off and the processor keeps the system clock running. Press any button to wake up the unit from sleep mode. Sleep mode is only useful for the Space Bits Are Us competitors to keep the clocks in multiple units synchronized. In all other cases, the unit should be turned off to better conserve power. Short pressing the left button allows you to cycle between menus. The device will display which top-level menu you are in by briefly flashing a color on all LEDs. The first menu is red and contains screensavers. Short pressing the right button allows you to manually navigate and select a screensaver. Long pressing the right button enables you to automatically cycle between screensavers and is the default. The first screensaver is a rainbow pattern. The second illuminates LEDs based on the ambient noise level. Blowing on the microphone will light all LEDs. The third screensaver blinks Morse code. The fourth shows a random blinking pattern. Exclusive to the Space Bits team is a fifth screensaver with a repeating white pattern. The second menu is yellow and is a cyclone timing game. The objective is to press the right button when the top LED is white. Each level is progressively faster. The third menu is green and is a gatekeeper game. The objective is to press the right button to change the top gate color to match the moving LED. The fourth menu is blue and contains a counter. Pressing the right button will increment the counter and display the value in binary. Long pressing the right button shows the time in binary. The LED color is not significant. The third mode is the developer interface. To communicate with the device, ground the swim pin. The status LED will illuminate red and all other LEDs will turn off. Do not press the buttons when the swim pin is grounded. Doing so may cause a short. Connect ground, RX, and TX to a USB to serial adapter and communicate with the device at 57600 baud. Note that the UART protocol requires a crossover between the master and device RX-TX pins. If you are unable to communicate with the device, try swapping these pins. The device will print a welcome message when the swim pin is grounded. Typing H and pressing Enter will show a quick reference guide of the terminal commands. Pressing P and entering up to 3 unsigned 32-bit decimal numbers separated by spaces will be echoed back to the terminal in hexadecimal. The T command with no parameters prints the time in milliseconds since power on. Passing in a value with this command will set the time. This feature is used to synchronize the screensavers across multiple space units. The L command will set one RGB LED. The first parameter is between 0 and 9 to select the LED. The second parameter is the RGB color, either 0, 1, or 2. The final parameter is brightness. The brightness is optional, and if not specified, will default to the max 255. The W command illuminates the front face LEDs on the space units. Similar to the L command, the W command accepts an LED index between 0 and 11 with an optional brightness value. The A command prints the ambient audio level in the room. The G command launches Minesweeper. Entering a row and column number separated by a space uncovers the selected square. Disconnecting the grounding on the swim pin at any time will return the device to application mode. There are 9 holes along the side of the unit. The first 2 are labeled 5 volts and ground. Switch off the device, then apply power here to charge the LiPo battery. The blue status light will illuminate to acknowledge 5 volts is present. The green status LED will remain lit until fully charged, typically a maximum of 3 hours. The Pony units have no undervoltage protection. Leaving the unit on to the point no blue LEDs illuminate will permanently reduce the capacity of the battery. To program the device, ensure the unit is switched on and the swim pin is not grounded. Then connect these 4 wires to an STM8 programmer: ground, swim, reset, and battery. ST Visual Develop and ST Visual Programmer were used to write the code and flash it onto the hardware, respectively. For detailed steps on IDE setup, refer to the GitHub repo linked in the description below. To ease electrical interfacing for charging, hacking, and programming, it is recommended to solder pins to the developer holes. One way to do this is to use 100 mil pins, push the plastic fully to one end, place the pins in the holes, solder the pins down, then remove the plastic. Note that this configuration has a high risk of shorting the dime cell battery on the Pony units. When installing more than the 2 pins for 5 volts and ground, it is recommended to remove the dime cell battery on the Pony units and supply external 3.3 volt power on the battery pin. The LiPo battery on the space units is held in place by double-sided tape and can be peeled off. Do not attempt to supply external power on the battery pin while the battery is installed to avoid damaging the battery. There is a pad near the processor where the analog voltage from the microphone can be probed with a DMM. For full design notes and schematics, please refer to the GitHub repo. Any comments, questions, thoughts, or concerns are deeply appreciated. Please leave them in a comment below.